Hello everyone. My name is Daichi, and I will give you a lecture regarding the radiation and remediation activities. So, let's start today's lecture. Today's theme is Kinds of Radiation and Their Characteristics, Volume 4. Are you ready? Okay, so far, amongst a lot of kinds of radiation, alpha ray, beta ray, and gamma ray have been focused on, and their approach for ionization, penetration power, as well as energy have been elaborated.
That's right. I think I have gradually understood their characteristics, and their difference.
I am glad to hear that. Today, taking account of their characteristics, let's learn the difference of impact, which they might cause on human bodies. In the last couple of lectures, we have learned that alpha ray travels straight after it is emitted, and stops immediately compared with other two kinds of radiation, after it ionizes other nearby materials, and it loses its energy. In addition, I talked that beta ray has less density of ionization, so it travels in a zigzag manner, and reaches farther than alpha ray. By the way, the travel distance of charged particles, like alpha ray and beta ray, is called range. Please remember this word, taking this opportunity. At last, gamma ray. Gamma ray has less density of ionization compared with alpha ray, and it sometimes disappears on its own way. Its penetration power, however, is large, and it travels farther than alpha ray and beta ray. Specific travel distances depend on their energy, but when considering travel through air, for example, alpha ray travels around a couple of centimeters, beta ray travels around a couple of meters, and gamma ray travels around a couple of tens of meters, or a couple of hundreds of meters. For the next, when considering collisions of radiations with human body, of course it also depends on their energy, but alpha ray travels around a couple of micrometers, or a couple of tens of micrometers. Beta ray travels around a couple of millimeters, and gamma ray travels sometimes a couple of centimeters within human body, but it could also penetrate human body, and travels farther. If we go into more detail, first of all, when considering external exposure, alpha ray stops at surface of stratum corneum, and doesn't go into deeper part of body. Therefore it doesn't make any impact on human cells. Regarding beta ray, if it has low energy, it also stops at surface of stratum corneum, and causes no impact on human body, as is the case with alpha ray. However, when its energy is comparatively high, to some extent, beta ray could travel through stratum corneum, and reach skin, or subcutaneous tissue. And if exposure dose is relatively high, it might cause impact on body with burn, for example. At last, gamma ray has much stronger penetration power, compared with alpha ray and beta ray. Therefore it sometimes reaches deeper part of body. Gamma ray, however, sometimes passes through body, and goes farther, as aforementioned.
Okay. So does it mean that regarding external exposure, alpha ray and beta ray with low energy might not cause problem on human body, and especially gamma ray needs to be cared about?
Yes, that's right. For the next, let's look at the case of internal exposure. First of all, regarding internal exposure caused by alpha ray, unlike external exposure, it could cause negative impact on internal human tissues. Impacted area might be limited to the area where radioactive materials exist, but it could make much bigger impact, compared with beta ray and gamma ray. With regard to beta ray, as is the case with alpha ray, internal exposure directly makes impact on human organs. Affected area will be larger than area made impacted by alpha ray, but its magnitude will be smaller, compared with alpha ray. And at last, regarding gamma ray, as is the case with alpha ray, as well as beta ray, it makes impact directly on internal organs. Magnitude of impact will be smaller than alpha ray, but it will influence not locally, but whole body. In addition, it sometimes travels from inside toward outside of human body, because its penetration power is very strong, compared with alpha and beta ray.
In other words, it means that regarding internal exposure, exposure derived from alpha ray also needs to be cared about, right?
Right. All kinds of radiations need to be cared about, regarding internal exposure, because there aren't anything to shield radiation from outside, like stratum corneum. At last, paper, aluminium, lead, and other relevant metals are taken as examples of shielding materials to explain the difference of penetration power of each kind of radiation. Therefore, I would like to touch upon it here, just for your information. First of all, as explained earlier, penetration power of alpha ray is weaker than beta ray and gamma ray. Therefore, it can be shielded by only a piece of paper. On the other hand, beta ray has stronger penetration power compared with alpha ray, and it can be shielded, for example, by a plastic or aluminium plate with width of a couple of millimeters or centimeters. At last, gamma ray has the strongest penetration power amongst the three kinds of radiation. It passes through a piece of paper or a thin metal plate, but it also can be extinguished, or even if not, its energy can be reduced by shielding with a plate of lead or iron. I will not go into detail, but I would like to emphasize that in order to obtain enough shielding effect, especially for gamma ray, not only materials themselves to shield radiation, but also appropriate width of the materials needs to be taken into account.
Okay, I see. Then, I think I now understand a little bit, difference of characteristics between alpha, beta, and gamma ray, as well as how they are used in our daily life, and what needs to be cared about, regarding exposure of radiation to human body.
There is no need to rush, but please learn them in a step-by-step manner. In the following lectures, relationship between exposure dose and actual impact on people will be gradually explained. So, let me wrap up my lecture by providing you the key points. First, today I talked about difference of penetration power between alpha, beta, and gamma ray, as well as their travel distance. It totally depends on their energy, but in the air, alpha ray travels around a couple of centimeters, and beta ray travels around a couple of meters, and gamma ray travels around a couple of tens or hundreds of meters. For the next, when radiation collides with human body, as mentioned before, it depends on their energy, but alpha ray travels around a couple of micrometers or tens of micrometers. On the other hand, beta ray travels around a couple of millimeters, and gamma ray travels around a couple of centimeters, or sometimes it passes through human body and goes farther. Taking account of these characteristics, difference of impact on human body was elaborated, caused by each kind of radiation. First, regarding external exposure, alpha ray doesn't make any impact on human body, because it basically stops at stratum corneum. And beta ray possibly reaches skin or subcutaneous tissue, if its energy is especially high. And at last, gamma ray could sometimes reach deeper part of body, or pass through body and go farther, because its penetration power is higher than other two kinds of radiation. On the other hand, regarding internal exposure, alpha ray makes small locally, but larger impact on human body, compared with beta ray and gamma ray, because it has higher ionization density. Beta ray makes in larger area, but smaller magnitude of impact, compared with alpha ray. At last, gamma ray has large penetration power, and makes impact in larger area, or on whole body, and even it sometimes passes through body, but it causes smaller magnitude compared with alpha ray. Of course, needless to say again, the magnitude of impact caused depends on amount of exposure dose and other factors, for both external and internal exposures. And at last, just for your information, materials are covered, which could shield each kind of radiation. First, alpha ray can be fully shielded by a piece of paper. For the next, beta ray also can be shielded by thin plates of aluminium or plastic. At last, regarding gamma ray, its energy can be reduced, or it can be shielded by thick plates of lead or iron. Especially for the shield of gamma ray, in addition to the materials used, appropriate width of the plates needs to be carefully considered. Okay, today's lecture is now dismissed. See you next time. In this channel, useful information regarding the radiation and remediation will be provided to you. If you like it, please subscribe to this channel, and do not forget to click the like button.